an example of a static equilibrium problem. Here we have an orangutan hanging from a system of ropes. This rope is coming straight down, this one is coming off to the side, and this one is coming at a 30-degree angle. This is merely a dotted line to show you where the vertical extends, which extends directly above his hand. In order to solve this problem, what we'd like to know is the tension in each of these three ropes, and we'll call this T1, T2, and T3. The weight of the monkey is 20 newtons. So, first we have to draw a free body diagram. Well, what we're really concerned about is the knot between these three ropes. So the free body diagram will be T3, T2, and T1. We know that because the monkey is hanging on the rope T3, if we consider a free body diagram of just the monkey over here, this dot is the monkey, we will have the force of gravity going down, and we'll have T3 going up. And since the force of gravity is 20, then T3 must also be 20. So to start the problem, we already know the value of one of our three forces. So to solve this problem, let's set up our summation equations based on the first condition for equilibrium. The sum of the forces in the x direction will equal mass times acceleration in the x direction. Sum of the forces in the y direction will equal mass times acceleration in the y direction. So let's go back to our diagram for a moment. T1 is all in the x direction, so we consider this to be T1x. We don't know what it is, but we know it's pointed in the negative x direction and that T1y is equal to 0 because there's no upward force on that string. T3, we know T3y will equal negative 20 because it's going straight down, and T3x will equal 0 because there's no horizontal component. But for T2, we're going to have to draw a component triangle. And this will be T2x, which is positive because it's pointing to the right, and T2y, which is positive because it's going up, and the angle inside is 30. So, I'm just going to write it right up here. I know that the sine of 30 is equal to the opposite, which is T2y divided by T2, and that cosine of 30 is equal to T2x divided by T2, just from my triangle relationships. I don't know T2, T2x, or T2y. All I know is the angle, but at least I have some relationships between them now. So now let's go back to our equilibrium equations. So what forces do we have acting in the x direction? We have three forces, negative T1x plus T2x, and T3x is 0. So we can put T3x here and then put 0 on the next line. Now how do we know the mass of the monkey? The mass of the monkey we find out from force of gravity. This is a subscript, equals mass times gravity. So 20 equals m times 9.8. So m is equal to 2.04 kilograms. Now 9.8 is a negative value, but what we want to know is the magnitude because the force here is downward, we already know that, and this will be negative because it's downward, but what we're looking for is the magnitude of the mass. So mass is 2.04. Acceleration in the x direction, the orangutan isn't moving to the up or down or side to side, so that's 0. Negative t1x, that's an unknown that we'd like to solve for. t2x, we don't know the value for t2x, but we can put in this relationship, which is t2 times cosine of 30 if I move this over to the other side. And you'll see why that's useful in a moment. And then t3x, we already said is 0, so we're going to leave that off this step. So now we have 0 equals negative t1x plus .866 t2. Now let's go down here and set up our y equations. Y, t1y, we know it's 0, but we'll put it in here for this step. t2y is positive, plus, oops, that's minus t3y, because 3y is pointing down, so we know it's negative. So mass again is 2.04, acceleration is 0, t1y, we said right here is 0, plus t2y, I'm going to do the same thing I did over here. I'm going to move t2 over here and get t2 sine of 30 minus 20. I notice we already put the negative in for this pointing downward, so I don't put negative in again for 20 because then I would have canceled out my negative. So let's simplify a step. 0 equals 0.5 t2 minus 20. Move my 20 over to this side. 20 equals 0.5 times t2. This is 1/2. So if I multiply both sides by 2, I get t2 equals 40. That's part of my answer because I wanted t1, t2, and t3. Now I know t3, I know t2, and I want to know t1. So let's take this up here, where I have an equation that relates t1 and t2. So 0 equals negative t1x plus 0.866 times 40. So if I move this to the other side, I get t1x equals 34.6 newtons. So my final answers are tension in this right here is 34.6 newtons directly to the left. This T2 is 40 newtons at an angle of 30 degrees to the vertical, and T3 will have a tension of 20 newtons straight downward. And that is the final answer to the problem.